Hello everyone, I think you all are keeping fine, and this is a new video related to differentiability. It's a very lengthy chapter and important also for your competitive examination as well as your class 12th. So this chapter has many topics, so I am discussing every topic with you. So still if you have any doubt you can post it to me. So in this video I am going to discuss with you the inverse trigonometric functions, means the differentiability of inverse trigonometric functions. I have already shared the videos related to inverse trigonometry, so if you haven't seen you can watch those videos, and I'll share the link in the description box so you can directly go through those videos. Otherwise it will be very difficult for you to have the idea of the domain as well as ranges that we are going to use. Okay, so how to start this differentiability of inverse trigonometric functions? Just see. First of all, I'm sharing the table of the domain and range of inverse trigonometric functions, because if you are having the table you can see the domain and the range, and my suggestion is you just remember it, because it's very important for the student, the one who is going to sit in the competitive examination, that you should remember the domain and the ranges as well as the graphs of every trigonometric function very well. Okay, so what is differentiability in this case? So let's see. In this video I'll discuss how to derive the formula, okay, like sin inverse x, cos inverse x, tan inverse x. So the derivation is not at all tough. You just listen and keep the pencil and the copy in your hand and go with my words. If you know one of the formula, it will be very easy for you to solve every formula. Okay, only you should know that how to technique actually basically. So you just see how to do that. Our aim is to find out dy over dx of sin inverse x. Okay, over x dx means we want to differentiate it with respect to x. Okay, so how to do that? First of all you let that sin inverse x equals to y. This is what we have written here. Now obviously you know that it's inverse function, so how can you write it? That you know that in inverse trigonometry we have studied it. We can also write it x equals to sin y. This is your first step. Okay, now this is easy to be differentiate. So we are going to differentiate x equals to sin y. So d over dx of x and d over dx of sin y. This is what I wrote here. So now you see d over dx of x is nothing but 1, that you know very well, and d over dx of sin y. Now here the variable is y and we are differentiating it with respect to x. So we have to apply the chain rule. So according to chain rule, first of all you sin y, you differentiate sin y as imagining that it is sin x. So this will be cos y. So you just write cos y here, as y is written in place of x because we are differentiating with respect to x. So we are going to redifferentiate it. So we are going to write dy over dx. We want to calculate dy upon dx. So dy upon dx from this line, it will be, this implies this is equivalent to 1 upon cos y. Okay, now just see, actually this is cos y and x equals to sin y we have written here, and this line. Okay, now you just see that what to do. You know very well that sin square y plus cos square y equals to 1. This is a very I think easy identity that you studied in 10th standard. Okay, now what is sin y is x, so x square plus cos square y equals to 1. From here you can calculate the value of cos square y. So this is nothing but 1 minus x square and under root. Okay, under root 1 minus x square. So this is what you got. Okay, now this is I have already written here, so you can go through these steps. So you will come to know that cos y is root of 1 minus x square. So this is the value of sin inverse x after differentiation, that can be written as 1 upon root 1 minus x square. What will be the domain of that? Obviously you know that in this case 1 minus x square. Okay, x square cannot be more than 1. Okay, the value cannot be more than 1. and it cannot be 1 also, because that will give you a 0. So in this case the domain will be minus 1 1, because you cannot go beyond minus 1 and 1. So that's why the domain will become minus 1 1. So this is how you are going to solve. One of the question I am leaving for you here, because generally whenever we solve the root we get the answer in plus minus, but I am not using minus here. So my question for you is that why am I not writing minus? Just think and answer me. Okay, now you see the next one. Next is d over dx, find out of tan inverse x. So how to derive? Same step. First of all you let it y, you will get x equals to tan y. Now you just differentiate it with respect to x, so d over dx of x and d over dx of tan y. So you will get tan y means sec square y and dy upon dx. Okay, now just find out the value, you will get this. Again you know very well that 1 plus tan square y equals to sec square y. So sec square y is 1 plus x square. So you will get in this answer. So this is very easy for you, and in this case there is no restriction on x, you can put any value, so you will get r. So domain of f dash is r. Okay, so this was very easy. See, actually you just keep an idea in your mind ki what to do whenever you are deriving a function. First of all you let it equals to y, and after that you differentiate it in an ordinary way. We have to use the chain rule because the variable is y and we are differentiating it with respect to x, and then you just convert that trigonometric function in terms of x by using the identity that you studied in 10th standard. This is very simple that we are doing. On the basis of this concept you can solve all the formulas. Okay, solve all the formulas, and if you get any problem you can freely discuss with me. See, this is what I wrote, all the formulas along with the domain of f dash. You just calculate and find out whether you are getting the same answer or not. Okay, just do that, and after that you solve your exercise based on the inverse trigonometry. I don't think that you will be having any problem in that. Thank you so very much, and just all the best for your studies. Just do that. Okay, thank you.